All right, I wanted to do a quick review of sampling distributions. These are all things that get talked about a lot in a lot of different places, but it's nice to have all of the information in one spot. So when we're talking about a sampling distribution, a lot of times these are the three things that we want to talk about: the mean, the standard deviation, and the shape of the distribution. Because if the shape is approximately normal, then that means we can use the normal distribution, normal CDF, to calculate probabilities, which is always helpful. All right, so first thing we want to talk about is symbols, and make sure we understand symbols. So for proportion, p hat, that is the sample proportion. Okay, p hat is a sample proportion. Just a p, regular p, is a population proportion. So if I want the sampling distribution of the sampling proportion, I'm talking about p hat. For the mean, sample mean is x bar, and then population mean is mu. Okay, so to find the mean of a sampling distribution, there's no conditions that we need to check. For a proportion, the mean of the sampling distribution for the sample proportion, that would be that symbol, mu p hat. This is the sample mean of the sampling distribution for a sample proportion. That is equal to p, the population proportion. And then same thing here, the mean of x bar, or the mean for the sampling distribution for sample mean, is equal to the population mean. Okay. Standard deviation. To calculate standard deviation, we need to know, we need to check the 10% condition. And so what we're looking for is our sample less than 10% of the population? Okay. If the population size, and that's noted with a capital N, if that is known specifically, if they tell you there are 8,000 students, all right, then I want you to show the math. I want you to show me that N, the sample size, is less than 10% of big N. Okay. But like we saw in our daily checks, sometimes we don't know specifically the sample size. They'll say all US teens, or all, adults between 18 and 25, or something like that. If it's unknown, we want to know if we can reasonably assume that our sample is less than 10% of the population. Okay, so like we did on our daily checks, we need to make a statement. We can't just ignore it because we don't know the exact value. All right, and you're going to say something like, it is reasonable to assume, and I put the sample and the population, I highlighted those because you need to put those in context of the question. All right, so it is reasonable to assume 20 students is less than 10% of all of the high school students. All right, so something like that. And for the sample and the population, make sure you put that in context of the problem. All right, so here we have our formulas for standard deviation. These are not things you need to memorize. All four of these boxes right here, these are all on the formula sheet that you get both for our testing class and for the AP exam. Okay, so don't worry about being able to memorize the formulas, but make sure you understand what all of these symbols are. So this would be the standard deviation of the sampling distribution for sample proportions, and this would be the standard deviation for sample mean. Okay, then the last thing is the shape, because if it's normal, that tells us whether or not we can use normal CDF. So for proportion, we're checking the large counts condition, and for mean, we're using the central limit theorem. Okay, so for proportion, all right, if n times p and n times 1 minus p are both at least 10, all right, then the sampling distribution is approximately normal. If you are asked to do this, make sure you show the math for both counts. So show me n times p. Don't just write n times p. Plug in the actual numbers from the problem. So show me that n times p is greater than 10 and that n times 1 minus p is greater than 10. All right. If one or both of these is not at least 10, then we can get an idea of the shape from the population proportion, p. All right, if it is close to 0, it's going to be skewed to the right. If it's close to 1, it's going to be skewed to the left. If it's close to 0.5, I would call it symmetric. I wouldn't be totally comfortable calling it normal or approximately normal. All normal distributions are symmetric, but not all symmetric distributions are normal. Okay, so if this up here is not true, then we're not going to use normal CDF, and you would not be asked about a probability. Okay, then for the mean, the central limit theorem tells me that if my sample size is at least 30, then the sampling distribution is approximately normal. Okay, if not, if it's less than 30, then it's going to match the population distribution. So if I have a sample size of at least 30, or if my sample size is small but it's taken from a population that is normally distributed, then I can use normal CDF. But if my sample size is small, aka less than 30, and it does not come from a population that is normal, then I would not be able to, and my shape would match that population distribution. So if the population skewed left, then my sampling distribution would also be skewed left with a small sample size. All right, so if you have not already, we want to make sure that all of this information is burned into your brain and that you understand. That'll give you your best chance at doing well on the Chapter 7 test.